So in this video we're going to look at the chapter review for Chapter 7 and work the problems that are in that section. So we're going to start with problem number 2. And I'm assuming that you have a book here, so I'm just going to write the answer. And the first problem says we have the equation A equals P times 1 plus RT. And we want to solve that for R. Remember what it means when we say that we're going to solve something for a variable is we're going to get that variable all by itself and everything else on the other side. Typically that's going to involve numbers, and we're going to have a whole bunch of numbers on the other side. But in this case we're going to have letters as well. So first thing we want to do is we want to get this parentheses all by itself. So we have a multiplication here. In order to undo multiplication, we would divide both sides by P. So that'll give us A over P equals 1 plus RT. Now we want to subtract 1 from both sides so we can isolate the RT. So we'll subtract 1 from both sides. We'll get A over P minus 1 equals RT. And then I want to isolate the R. So I have a T here. I can do that two ways. I can either multiply both sides by T, by 1 over T, or I can divide both sides by T. So if we divide both sides by T, we get this. All right, so you could have the following as an answer. A minus P minus 1 over T. Or you could also multiply both sides by 1 over T. And if we multiply both sides by 1 over T and distribute that, we're going to get A over TP minus 1 over T. Both of those are going to be the same answer. This is a little bit cleaner. This one is what we call a complex fraction because it has a fraction within the fraction. But they're both okay. The other thing you could have done is you could have gone ahead and distribute the P first. So if we do that, we would get A equals P plus PRT. And in that case, we would subtract P from both sides. So we get A minus P equals PRT. Divide both sides by PT. And we would get R equals A minus P over PT. Now notice these are actually the same. If I was to get a common denominator here of TP, I'd multiply this by P in both numerator and denominator. I'd have my common denominator of PT, and I'd have A minus P in the numerator. I would get the same thing here if I multiplied both numerator and denominator by P to isolate or to get rid of the complex fraction. But this is a viable answer. This is a viable answer. This is a viable answer. Okay, let's go to number 7. In number 7, we're told that WIN is considering 2 satellite TV systems. Global Communication charges $240 for installation and $39 per month. World Communications charges $350 for installation and $28 per month. After how many months will World Communication be the better buy? So what we want to do on this is come up with linear equations for both of these. So for World, the cost for World is going to be the original charge for installation of $350, plus we're going to pay $28 a month. So if M is the number of months, this would be our total cost, the $350 installation plus 28 times however many months we're looking at it. So that's for World. For Global, our cost is going to be $240 for installation plus $39 times the number of months that we've got that plan going. Now what we'd like to do is notice that Global is starting out cheaper, But world is going to be cheaper in the long run just because it's less per month. So what we'd like to do is find out the month at which these costs are the same, because before that month, global is going to be the better buy. After that month, world is going to be the better buy. So what we want is we want these two costs to be equal to each other, so we can set this part of the equation equal to that part, and that would make our two costs equal to each other. So if I said cost 1 and cost 2, and I want cost 1 to equal cost 2. All right, so when I do that, I'm going to get 350 plus 28m is equal to 240 plus 39m. I'm going to get all the m's on one side and all the numbers on the other side, so I'm going to subtract 240 from both sides. And I'm also going to subtract 28m from both sides. That's going to give me 110. These will cancel out. Those will cancel out. And I will get equals 11m. So divide both sides by 11. And I get m equals 10. So my answer would be after 10 months. Because it wanted to know when is world going to become a better bargain. So that'll be after 10 months. All right, the next one is number 10. On number 10, it says the amount spent by Americans on foreign travel increased from $81.8 billion in 2002 to $99.9 billion in 2005. Model this information with a linear equation. So the first thing we need to do is we need to find out what our variables are. So let's let t be the number of years since 2002. And I'm going to use 2002 just because that's going to make that first point have a 0 in it, which is going to make things easier for me. And I'm going to let cost, or let's say amount, A for amount spent on travel. Alrighty. Now, what they've given us is they've given us two pieces of information. So what I need to do is I need to come up with two points that will model that information they give us. So I'm going to let this act as my x's and this act as my y's. So I'm going to be looking at TA coordinate pairs. And so with the first one, I have in 2002, so the number of years since 2002 would be 0. The amount spent is $81.8 billion. And for the second point, the years is 2005, so that would be 3 years since 2002. And the amount spent is $99.9 billion. And I'm going to leave everything in billions. And I'm going to notate that up here in billions. All right? So if I want a linear equation for this, notice that this is actually going to be my b in the y equals x plus b form. And now what I need to do is I need to find my slope. So my slope is going to be the change in my y, or the change in my independent variable. So it's going to be 99.9, my dependent variable, minus 81.8 divided by 3 minus 0. So 99.9 minus 81.8 gives me 18.1 over 3. Divide that by 3, and I get about, I'm going to round that off, 6.03. That's going to be my slope, and I said this is already going to be my y-intercept because of the way I set up my variables. So I'm going to get A is equal to my slope, which is 6.03 times t plus 81.8. And that's part A, my my linear equation. Part B says we want to take that equation and we want to estimate the amount that will be spent by Americans on foreign travel in 2015. So 2015 would be a t-value of 13 because it's going to be 13 years since 2002. And I'm just going to plug that 13 in, 6.03 times 13 plus 81.8. 6.03 times 13 plus 81.8 gives me 160.19. So remember, that is in terms of billions. So my answer would be $160.19 billion. In that year. So that's number 10. All right. Number 14. Number 14, we want to answer the following questions for the graph of the equation y equals negative 2x squared minus 10x minus 8. The first question we want to ask is it opening up or down? And that's determined by this A term out here. Remember, we have an A out here, and then this is going to be your B, and this is going to be your C. And if your A is negative, it means it's an opening downward parabola. And if it's positive, it's going to open upwards. So this opens down. Part B, we want to know what the vertex is. So for the vertex, we remember that x, the x-coordinate for the vertex, is minus b over 2a. So in this case, the opposite of b, our b is a negative 10, so the opposite of that will be positive 10, over 2 times our a, which is negative 2. So that's going to be 10 over negative 4, which is going to be negative 2.5. That is our x value. Then to find our y value, we're just going to stick that value back in and find the y. So we'll have negative 2 times negative 2.5 squared minus 10 times negative 2.5 minus 8. And so let's see what I get when I do that. Negative 2 times, parentheses, so here's, I'm going to use the calculator here. Negative 2 times, I'm going to have parentheses around the 2.5, the negative 2.5, and then I'm going to square that. Minus 10 times negative 2.5, and we have minus 8. So my answer is 4.5. So my vertex is going to be negative 2.5, 4.5. All right, the next question is, what are the x-intercepts? So for the x-intercepts, what I'm going to do is I'm going to let y be 0. So I'm going to stick a 0 in here for y, which gives me a quadratic equation. And I can either solve that using the quadratic formula, or I can go ahead and try and factor this. This one factors pretty easily. So what I'm going to do is I'm going to get rid of the negatives first and get rid of this 2 out here. And I'm going to multiply both sides by negative 1/2 to make things a little easier, which gives me 0 equals x squared plus 5x plus 4. And now you can see that that factors pretty easily. X plus 4, x plus 1. We let each of those factors equal 0. So my two values are negative 4 and negative 1. So my x-intercepts are negative 4, 0, and negative 1, 0. Or if you use the quadratic formula, remember that is the opposite of b, which would be positive 10. plus or minus the square root of b, negative 10 squared, minus 4 times a, which is negative 2, times c, which is negative 8, all over 2 times a, which is negative 2. And when you do that out, you should get the same answer. All right, because you'll get 100 here. That'll end up being minus 64, so that'll be a 36 under here, so you'll get a 6 out of there, so it'll be 10 plus 6, which is 16 divided by negative 4, which is negative 4. You'll get 10 minus 6, which is going to be 4, divided by negative 4 is negative 1. Okay? So those are your x-intercepts. To find your part D, your y-intercept, you let x equal 0. And if you let x equal 0 in your original equation, notice that term's gone, and you get y equals negative 8. So y equals negative 8. So your y-intercept is 0, negative 8. And then you want to do a quick graph of this equation. So we have x-intercepts at negative 1 and at negative 4. We have a vertex at negative 2.5 and 4.5. And we have a y-intercept at negative 8. And it's opening down. So there is a graph of our parabola. So that's number 14. Okay, let's move on to number 16. Number 16, we want to assume that the equation A equals negative 0.125x squared plus 2x plus 1.125 models the attendance of a recently released movie for X weeks. During what week will the movie attain its highest attendance? Well, since this is a parabola, because it's an x squared, and since it's opening downward, that means the highest that it's going to hit is up here at the vertex. So all I need to do is find the vertex. And my two variables here are x, which is number of weeks, and a, which is the amount of, or the attendance. So what I need to do is find the x-coordinate for my vertex, because that'll tell me the number of weeks. So remember, that is x equals the opposite of b, so that would be a negative 2, over 2 times a, which would be negative 0.125. So when I do that, negative 2 divided by parentheses 2 times negative 0.125, I get 8. So in the 8th week is when we're going to have the highest attendance. And then if we wanted to know what that highest attendance is, we would stick that value of 8 in for x, and that would tell us the highest attendance amount. All right, number 17. Says if $10,000 is placed into an investment paying 4.8% yearly interest compounded annually, how much will be in the account after 5 years? All right. So this is in Chapter 7, so we could use the formula from Chapter 7, but I like using this formula all the time because anytime I have compounding interest, it's always going to work. Now, what I want to know is, what do I have and what am I trying to find? So $10,000 is what I'm starting with, so that's going to be my P. Is placed into an investment paying, so I have an interest rate of, remember, we always have to turn that into a decimal point. So it's 4.8%, but we turn it into a decimal number. So it would be 0.048 divided by n, which is the number of compounds per year. Since this is annually, it would be a 1, raised to the n, which is 1, times t, which is 5 years. And what I want to know is what is A. So now I would get my calculator out, and just for practice, I'm going to plug the whole thing in. 10,000 times 1 plus 0.048 divided by 1, close parentheses, raised to the, and then typically I would need parentheses for all of this stuff in the exponent, 1 times 5. And that gives me 12,000, and I round it off, $12,641.73. Okay, and lastly, number 18. Number 18 says, how long will it take for the account in exercise 17 to double? So we're dealing with the same thing as we had up here, but now we know what the amount is at the end, and what we're trying to find is the t. So if we want to know when it's going to double, we start with 10,000. We're going to end up with 20,000. And I'm going to simplify this a little bit. 1.048, I'm going to add those together. 1 plus 0.048 is 1.048. Raised to the, this is still a 1, and so what I'm trying to solve for is my t. Now the first thing I'm going to do is I'm going to isolate this exponential, so I'm going to divide both sides by 10,000. Which will give me 2 equals 1.048 to the t. Now, anytime we have an exponential function like this, remember the way that we solve that is using logarithms, and we can either use regular logarithms or natural logarithms. I prefer natural logarithms. So what I'm going to do is I'm going to take the natural logarithm of both sides, and what that allows me to do is anytime I have an exponential within a logarithm, it allows me to pull my exponent out in front and make it a product. So this can be rewritten as t times natural log of 1.048. Remember, that was a property of logarithms. Now, this is just a number, so I'm multiplying by a number. So in order to solve for t, I'm going to divide by that number. So I'll get t is equal to, plug in natural log of 2 divided by natural log of 1.048, and I get 14.78 approximately. So I can say about 15 years. And those are the problems from Chapter 7.